All right. All right. Can you hear me in the Prasanna? Very good. Okay. So we'll get started. Like I said, I will present a couple of things, or maybe 2 or 3 projects. In these presentations, if you have any questions, stop me there and ask questions. Okay? There's no problem. There's nothing formal about it. Just informal presentation. So the first one I'm going to talk about is box beams. These two students are, or those two co-authors are my students who finished PhDs on this project. So we are trying to find out, or this research is on effectiveness of longitudinal joints in adjacent box beams. So I'll go over many things. I will go over a few things. At least I will skip a few things. But what's a box beam bridge? In the US, they have there are some standard spans. If you have two highways, one on this side, one on this side, and then you have some little bit of divider, so to speak. So the span is about let's say 50-60 feet, which would be divided by 3, about 20 meters. 20 meters. So 18 to 20 meters is very standard size bridge, span wise. Width is always about 12 meters. Almost always, you'll see 12 meters width in many cases. So what they do is they make precast box beams just like this. They make hundreds of them, and then they bring it to the site, put them all together, and then they tie them 3 at a time. 3 beams at a time. That's what they do. So they're all tied together, and there is a joint here. So each location there will be annular space, and in that annular space, in the annular space, they fill just grout. If you put grout, then the assumption is they will all work together. So those of you who are familiar with highway bridge design, our standard width of a axle is about 6 feet. 6 feet is about how much? 2 meters? About 2 meters. Less than 2 meters actually. So these are smaller than 2 meters. So if all these beams are working together, you can assume some kind of load transfer over more than one box beam. That's the assumption. That's the whole point of making this work together. If that happens, it's great. If it doesn't happen, then your boxes will be stressed too much. If you design it for a smaller load, assuming that there is perfect action between adjacent beams, then it will become unsafe. So the typical details look something like this. You have a lot of strands. These are mostly pre-stressed strands, not post-tension, but pre-tensioned, pre-stressing strands. And they have very long casting beds. Did any one of you go to any pre-casting plant yet? If you have, or if you haven't, just go to something nearby. Generally, they have 100 meters, 150 meters long bed, and they make these box beams in one long stretch. So each bed you can make 10 beams, maybe 8 beams, depending on the span, and then they cut the strand in between to make it to have smaller beams. Okay, so in one day they can make 20 beams. One day. That's how fast it is done. You place the concrete and let it set, and then cut the strands, then remove it from the formwork. You remove that in less than 15 hours, 12-15 hours, and then again they make preparation for the next set of beam. So it's a very fast process. and each beam is less than $20,000, very little money. So, so these beams are very, very inexpensive to make. So there are at least 20,000 of this kind of beams in just one state. So this kind of bridges, not beams, bridges. Each bridge will have 8 or 10 boxes. So it's a very common thing. But the whole problem is these joints tend to leak. You can see how these icicles are formed. You can reduce the light in the front. Can you turn this off just for 1 minute, front light? Yeah, just for 1 minute. So you can see how the water seeps through here, and because it's very cold, it becomes icicles like that. So that's ice. And then with ice and to keep the ice from becoming hard, you spray a lot of salt, chemicals. So nowadays, the people who maintain the roads, they don't care about structural performance, right? So they put very aggressive salts, 30% salt solution. 30%, it's like very, very strong brine solution. They spray on that, and that's a very high concentration in salt, and this is what happens when there is corrosion. So all these strands, they break, not all, but many of them, and they start falling down onto the road below the bridge. So it's a real problem. So in this project, we were given a project to improve the performance of this kind of box beams. So we looked at these three aspects: membrane performance. So I think I will go back 1 minute and explain what it is. So once you place these box beams side by side, you grout these joints, then you put some membrane, which is waterproofing membrane. You place on top of it, and then on top of it you put 50 millimeter asphalt wearing course. So that's the process. So first you have the box beams, then you have a membrane, and then you have asphalt wearing course, 2-inch wearing course. So very quickly you see that within matter of weeks, these box beams crack at the joint. So that's a big problem in many parts of United States. So they are willing to invest a lot of money to do research, and they asked me to do some work on that to improve the performance. So we looked at membrane performance. This may not be very interesting to you, this part. So we looked at various different aspects of membranes. We picked a lot of membranes. I'll go fast because we don't have that much time. But we did a lot of tensile tests. We did some peel out tests. We did shear tests, and so on and so forth. And then we did waterproofing tests, everything. What we found was everyone thought membrane is not working. That's the reason there is leakage in the joints. But we found that the membranes are perfect. They are not really causing any problem in terms of water leakage. Okay. Then we started looking at the joints. So the joints will look something like this. The standard joint is this one. It's a very small joint. 3/4 of an inch means 20 millimeter opening. So you place your grout through that opening, and here you have about 40 millimeter width below the top surface. So you place your grout through that, and then once you place the grout, you think it's okay, it's working. And then we tried different types of geometries for the keyway. Keyway means the joint geometry. I think this is one of our students who Jagdish knows. I think that's Srikant. That's Srikant. So tell him we are all the class. They looked at your picture, and just tell him he looks very handsome. He is handsome anyway. So so we have so many different kinds. Then we did a lot of beams with very long spans, and we actually tested these joints. I will go a little bit quick because that's what we will need to finish these presentations within the 2 hours time slot. So we tested about 25 feet, about, let's say, about how much? Up to 10 meter length beams we were able to test, and we tested all those almost full scale. We tried many different grouts, and then we came up with a special grout mix design which improved the strength by a factor of 5 or 6, which was very good. Then we did a lot of finite element analysis, abacus analysis, and we were able to actually find out the stresses at the joint, and then we tried to improve the joint performance by making the joint deeper. So by making the joint deeper, we have far little the stresses are way below what we are expecting at this time with shorter height. So we did many different types of analysis, and once you do the analysis, you want to actually simulate the analysis results in in the laboratory tests. So that's what we did. Hundreds. My students, they like to do hundreds of, or not like to do, but they do hundreds of tests to get proper standard deviation and to get reliable results. And it's lots and lots of work. In American universities, we don't have technicians. So each of my student is a technician. I am a technician. Everybody is a technician. You do your own thing. All these casting, my students do this. The testing, they do it. But it's somewhat advantageous because you have very good cranes. We pick them up, place them, everything. One person can do everything. So that way we improved the joint condition. We looked at the tie rod effectiveness, keyway geometry, grout type. I'm not going through all the details. Joint surface preparation, sandblasted joint surface preparation, and as cast surface. And then we looked at the current specifications and then suggested some suitable modifications. So that's the sequence of all these tasks. So then we actually did, they were tearing down some bridges because they're too old. But many times I feel so bad that the bridges they are tearing down there, if I can ship it to India, they will be some of the best bridges in the country. No, I'm not joking. I sincerely feel very sad when they are tearing down such beautiful bridges, because they just don't want to deal with maintenance. A little bit of maintenance, you can actually use that bridge for next 30 years. But anyway, my student actually cut some openings and then he removed the membrane. After 30 years of service, we removed the membrane and found that the membranes were really in bad shape. So we had some specification changes to reflect that kind of poor performance of membranes. Okay. Then we also looked at the construction process, and my students, they went quietly to the construction site, and then those guys, you won't see many people in the construction site in US. You'll see 2 or 3 or 4 people, that's it. Because everything they're lifting with cranes, they're doing this, doing that, so you won't see many people. So they told them, oh, we don't know anything about box beams, will you please teach us how to do it. And they are so sincere, they think that's true, and then they keep on explaining everything they do, but many things they do are not really right things to do. But they will tell them, okay, we do like this, okay. Then quietly these guys, my students, they recorded everything, and then you say thank you, goodbye, everything. And then in our report we wrote that some of the things that are practiced in construction site, not very good. So this grout, they make that grout and then they place in the joint. So at the bottom they seal it with some kind of oakum, like it's like jute rope. It's like that, but it's not that. So put it there and then seal it. So they don't care because first of all they cannot see. The opening is so small you cannot really see. They just put it inside the inside at the joint, and that's all. They place the grout. Tell me where the grout is going. Can you see it? I don't know if you can see the picture very well. They are placing grout. This is watery, very, very watery, right? Those are all ready mixed grouts. So what they do, they say in the instruction it tells you just add water. That's what they say. So they just add water, literally. They'll pour water, keep on pouring water until it becomes really watery. And then they place it in the grout, in the joint. And can you tell me where that grout is going? Right here. It's all green, you can see that. That's it. That's an environmental disaster. And if the inspectors come, they will simply fine them tens of thousands of dollars. But anyway, that's what they do. And then we also had a lot of field measurements. Our students, Habu, Abdisa, this is probably Shrikant, Jagdish. You can tell him again. We saw you so many times in the pictures. So, and then we measured all the deflections, and we did our analysis. When I say we, my students, of course, did the analysis. They compared the actual deflections with measured deflections, and the deflections are very, very small. You have it here. It's about 0.01 inch. How much that would be? 2.5, 25, 1.5, less than 3 millimeter, I think. About 3 millimeters, okay? Less than 3 millimeters. So for a 60 feet span, you get very small deflections. So the joint is not really seeing too much of differential deflection. And then we change the specifications, right? So we actually have to verify those, change specifications. They won't let us use that as a standard until we validate it full scale validation. So we change the joint type. That's the only thing they will let us change. We change the joint shape, the surface shape. This was the original shape on the surface of the box beam, and then we made it much deeper, much wider, and we gave them the specification for grout material. Worked very good. We actually implemented that. We are in a site. This is a bridge site where these are the joints. They placed the grout. It nicely filled the keyway, and it's flowing really. It was really flowing very well. Before we placed it in the joints, we actually tried it in the precasting yard with 2 blocks of concrete with the exact same width as what we expect or what we specify in the drawings. And you can see the grout is flowing so well, flowing all the way down. And that's the miracle of modern day admixtures. You add admixtures with proper dosages, you can get, this is just like water. But at the same time, it's very, very strong. The strength is not lost at all. So that's the advantage of admixtures. So everything looked good. Then they placed the asphalt topping, and then perfect, no cracks. So they are going to implement this. After I go back in a week or two, we have a big meeting with the all the precast industry guys. So I'm going to convince them to use these details. They are just a little bit reluctant because they have to change the formwork. So if we can somehow compensate for the change in those they're all steel formworks, by the way. So they make it once, they use it for 20 years. So they don't want to make any changes because it will cost money. So I will we are going together. I'm going together with Ohio Department of Transportation. So together we will give them a deal, say, okay, we'll pay you this much money, you change the formwork, and then they may agree to change everything. So based on this, what I have presented in less than 15 minutes, I think, less than 15 minutes, I presented to you 3 years of work, 2 PhDs, a lot of work. They worked so hard, day and night. They were working very, very hard. So Jagdish wants to come for his PhD to me. I said, I scared him. This is what you are going to do. Are you ready to do that? If you are not ready to do that, don't come. A lot of hard work, So, um, so finally we found that membrane failure is not the problem, and then we made changes to the current specifications. We implemented, showed that it works, and therefore it's a good solution. Hopefully we will implement it in a large scale. The specification for the department will change based on this work, and we are very proud of the results we got. Okay, any questions? Yeah. And all the beams will act independently? No. They are independent up to the point where you put the ties and then grout it. Once you grout it, they are supposed to be working together, but they don't. Because the load has to be transferred from one beam to yes. There should be shear transfer. Right, absolutely. You said the right thing, yes. Either dowels or the surfaces should be I agree. You are just saying exactly what I agree. That's right. You are right. And that small keyway with smaller depth to the shear connection. The shear connection is only over a small depth through the grout. So it was not working. In fact, the grout was not even filling the void. So with the change details, it's perfect. Oh, no. Everything costs money. You change any design. See, even changing the keyway geometry is so hard because the contractor is so geared up to do certain things certain way. They have been doing this forever. You make changes, they will mess it up, and then they will blame us for, contractually we will be liable. They can sue us for millions of dollars. So that's the problem in US. Anything is all litigated. Legal and lawsuits are a problem. Yes, sir. So can we reduce the leakage and increase the strength of bridge by doing post-tensioning in transverse direction? Oh yeah, post-tensioning. We have done that also in one of the bridges in, not we, but I was not personally involved in that, but my collaborators in the department, they did that. They used carbon fiber to post-tension, carbon fiber cables. The ones I showed you here, these are from that project. So they use this carbon fiber. But there is a lot of difference. When you are saying those beams, they are cast in the precasting yard. They have the formwork, everything geared up to do those kind of beams. 15, 20 beams in a day. In one day they can make 15, 20 beams, no problem. So imagine the turnover, right? Turnover means how quickly they are doing it. And then how cheap it is or cost effective it is to make those beams. But if you are doing cables and post tensioning at site, at that height, that's going to be very, very expensive. That's why you can do post tensioning, but it costs a lot of money. Some of the devotees, they are using only that kind of post tensioning. They are not using just tie rods. Anything else? Okay, so the next presentation I'm going to show you is, it's on bridge decks, just slab bridges. So cracking is a big problem for structural slab bridges. So this is another project where we looked at reducing the crack widths and extent of cracking. And this is my student Shrikant Marshetty, who finished his PhD. Now he's working in Hyderabad as a faculty member in one of the colleges there. And 100%, he did all of the work shown in this presentation. So in addition to, if you have a small stream, typically you have this kind of bridges. where you have 3 spans. One span, you can't see the abutment here and abutment here, but you have 2 piers, pier caps, support here, one abutment here, one abutment here. This is a full depth concrete, reinforced concrete bridge deck. So you have 3 spans, and 2 of them, these supports are continuous